All right, if you've ever been a developer on a big modern app, you know the feeling, right? You've got dozens, maybe hundreds of moving parts, and they all have to work together perfectly. It can feel like absolute chaos. Well, today, we're going to explain the system that brought order to all that chaos: Kubernetes.
So here's our game plan for today. First, we're going to unpack the problem that Kubernetes was built to solve. The crazy complexity of modern apps. Then we'll dive into what Kubernetes actually is and get under the hood to see how it works. After that, we'll look at how you use it to deploy an application in the real world, and then we'll tie it all together to see why it has become the undisputed king of modern infrastructure.
Okay, so to really get why Kubernetes is such a huge deal, we need to rewind the clock a little. Let's look at the world before it became the standard. This is really where the whole story begins.
And that's a really important question. The short answer is that applications themselves changed a lot. We moved away from building these giant single programs, what we call monoliths, and started building things in a way that's way more powerful, but also just way more complex to manage. See, instead of one giant application, modern systems are built using microservices. Think about a banking app. You don't have one giant program anymore. Instead, you've got this whole collection of tiny independent services, one just for logins, another for handling transfers, and so on. This makes development way faster, but it also creates this massive new challenge of how to manage hundreds of moving parts. And honestly, this created a total management nightmare. For every single one of those little services, an operations team had to manually set up a server, install all of its specific software, and then watch it like a hawk. And what happens if the payment service gets a huge spike in traffic? Well, you'd be scrambling to spin up new servers by hand. I mean, this whole manual process, it wasn't just slow and crazy expensive. It was a recipe for disaster. This was the chaos we had to solve.
So, out of all that chaos, something had to emerge to bring some order, right? An orchestrator, a system designed not just to manage all this complexity, but to actually thrive on it. And that system is Kubernetes.
This is truly the best way to think about it. Kubernetes, or K8s as you'll hear it called all the time, takes all your individual microservices and just makes them work together in perfect harmony. It automates all the hard stuff, the deployment, the scaling, the management, so you can get back to focusing on building your app, not just babysitting it. Now, to pull off this magic, Kubernetes stands on the shoulders of another critical piece of tech, the container. If you've ever used Docker, you know exactly what I'm talking about. A container is basically a standardized little box that bundles your app's code with everything it needs to run, all the libraries, the configuration, the whole shebang. The result is this perfect portable package that runs exactly the same everywhere. Finally solving that classic, but it works on my machine problem we've all dealt with. Okay, now this is super important. Kubernetes doesn't actually manage containers directly. It has its own special concept called a pod. A pod is the smallest thing you can deploy, and it's basically a wrapper around one or more containers. And this is so powerful because the pod gives those containers a stable home with a shared network IP address and storage. It lets Kubernetes treat them as a single cohesive unit. Seriously, understanding the pod is key because everything else in the cluster revolves around it. All right, so we get it, we have pods, but where do these things actually live? To answer that, we've got to look at the architecture of a Kubernetes cluster itself, the machine that brings all this order to the chaos. So at a super high level, a Kubernetes cluster is made up of two types of machines, or what we call nodes. You've got the brains of the whole operation, which is the control plane. You might have heard it called the master node in the past. And then you have the muscle, a whole fleet of worker nodes. The control plane calls all the shots, and the workers are the ones that actually do the work. And this split is really the key to how it all works. The control plane's job is to maintain the state of the entire cluster. It decides where to run your applications. It reacts when things fail. The worker nodes, on the other hand, are the ones that do all the heavy lifting. They're the servers that actually run your application pods and provide all the computing power. So if we crack open the control plane, we find four key parts. First up, the API server. Think of it as the front door. It's the only way you or anything else can talk to the cluster. Then you've got the scheduler, which is the smart component that figures out the best worker node to place a new pod on. The controller manager. This is the real heart of Kubernetes self-healing magic. It's constantly checking to make sure reality matches what you asked for. And finally, there's etcd. This is the cluster's memory, its source of truth for all configuration and state data. So on each one of these worker nodes, you've got two little agents that are just waiting for orders from the control plane. The first is the kubelet. It's the main agent that talks to the API server and makes sure that the containers inside a pod are actually running and healthy. The second is the kube proxy, and it's all about networking. It manages all the complex network rules on the machine so that your pods can talk to each other and to the outside world.
Okay, so we've seen the architecture, the brains, the muscle. But how do you actually tell this beast what to do? How do you get your own application up and running on it?
Well, you do it with something called a deployment. And trust me, this is an absolute game changer. It's a declarative model. That means you don't tell Kubernetes how to do something. You just tell it what you want the end result to be. You just write a file that says, hey, Kubernetes, I want 3 copies of my web server running, and the deployment goes out and makes that happen. And it keeps it that way, no matter what. This declarative power is how you manage application updates. The most basic way is the recreate strategy. It does exactly what it sounds like, kills all the old pods, then starts up the new ones. It's simple, sure, but it means you'll have downtime. The defaults and much smarter approach is a rolling update. Here, Kubernetes gracefully replaces the old pods with new ones, one by one, making sure your app stays up and running the whole time.
And it gets even better. This declarative approach unlocks some really advanced deployment strategies. With blue/green, you can have 2 full versions of your app running at the same time, and then just flip a switch to send all traffic to the new one. 0 downtime. Even safer is a canary release. This is where you can dip your toes in the water, right? You send just a tiny bit of traffic, maybe 1% of your users, to the new version. This lets you see how it performs in the real world before you commit to rolling it out to everyone. It gives engineers so much control and confidence. So when you put it all together, the architecture, this declarative model, the super safe deployment strategies, this is exactly why Kubernetes isn't just some cool tech. It's the industry standard for running modern software at scale. Let's connect the dots to the real-world impact. All this cool tech translates directly into huge business wins. You get cost savings because Kubernetes is brilliant at packing your apps tightly onto fewer servers. You get high availability because it's always watching and will automatically restart anything that fails. It can scale up to handle huge traffic spikes without anyone lifting a finger. And, maybe best of all, you get vendor independence. It works the same everywhere. AWS, Google Cloud, Azure, even your own data center. You're not locked in. And look, the industry has totally bought in. I mean, get this. A recent report from the Cloud Native Computing Foundation found that 96% of organizations are already using or evaluating Kubernetes. This is so big that it's changed how companies are even structured. That same 96% now have dedicated platform engineering teams whose entire job is to manage these internal platforms built on systems like Kubernetes. It's not a side project anymore, it's a core part of the business.
And this is not slowing down, not at all. Looking ahead, that same report says that in the next 5 years, a whopping 80% of companies plan to build most of their new apps on cloud-native platforms like this. So if you're wondering if this is just a trend, the answer is a clear no. This is the future of how we build software.
And this is probably the most important thing to understand now. Kubernetes has grown up. It's not just for simple little web apps anymore. The technology is so stable and trusted that companies are now running their most critical, high-stakes applications on it. We're talking their core databases, their real-time analytics, even their complex AI and machine learning pipelines. That shows an incredible level of trust in its power and reliability. You know, it's wild to think that about 10 years ago, Kubernetes came out and started to bring order to this microservice chaos. It gave us a common language, a powerful set of tools to build systems that are resilient and can scale to incredible heights. So it really makes you wonder, right? What are the problems that the next generation of this technology is going to solve? What new order is going to emerge from tomorrow's chaos?